So the quiz is next week on Thursday. So yes, quiz. I've almost covered almost everything that's on it, but there are still a couple things. So let's talk about those things. Just a review of what a definite integral is, right? So a definite integral is the area under a curve. So when we have a function f of x, then this definite integral corresponds to the area that is bounded by the function and the x-axis, right? So if this is the x-axis, we're looking at this area here. Why is this? I've got to share my screen. Yeah, so we're looking at this area here between the values x equals a and x equals b. Riemann. Riemann. It's a guy, some name. Okay, and as you guys remember, if f of x dips below the x-axis, then the area is going to become negative. So if we have a situation where f of x is smaller than 0, maybe like this, then we have a negative area in this case. Okay, any questions? You guys should also remember various properties of definite integrals. So when we switch the limits of integration, that's what we call a and b, lower and upper limits of integration. When we flip them, the area is going to become negative. So if we have b instead of a at the bottom, then the area is negative because we're always calculating area from left to right. So if we suddenly start calculating area from right to left, it's going to become negative. What else is there? We also, if we have a constant c that's in front of the thing inside the integral, we can always pull that out. So we can have the c come to the outside, and that's fine. Any questions about this? So I think on the classwork, which you guys should all be able to do at this point, it's just going to give you, for example, is there an extra copy? Okay. Okay. You can give it to Hudson. Yeah. Give it to Hudson. So, for example, what's a good example? I think these are all fairly straightforward here. But you should think in terms of the area, right? So as an example, if we had, if we're told that um you. Let's say we're told that the integral of f of x from 0 to 4 is equal to 2. That's telling us that the area under f of x, so the area in between the x-axis and f of x between 0 and 4 is going to be 2, right? So that means if we switch the limits of integration, we're going to have a negative area now. It's going to be negative 2, right? What if we had something like the integral from 4 to 4 of f of x? What would this be? Why?
No, it would be yeah, it would be 0.
Yeah, it would be 0 because we're calculating an area of 0, right? If you think about it graphically, if we had our function here, if we have the same upper and same lower limit of integration, then that just means that we're calculating this area, right? It's the same x coordinate, and so the area is obviously 0.
It's 4 and negative 4. So, right, these will be flipped sides of the graph.
We don't know about negative 4 right now. We're only given this information here. Okay, So integrals can also be added. So for instance, if we were told that the integral of f of x between 4 and 6 is maybe like -1, then that means we can add these two integrals, right? Because that corresponds to a situation where we have, 0 to 4 and then 4 and 6. And so that means the integral of 0 to 6 is just going to be the sum of those two areas, right? That's pretty obvious geometrically. So 2 minus 1 equals 1. Okay. That's just because we're now combining two separate areas. This area and this area. 0, 4, and 6. Any questions, Vincent? Yes. I don't know. I don't know where they are. Thank you, Brock. So that should be pretty straightforward. So let me just review some methods for calculating area just for the back page. So remember that the area of a circle is pi r squared. All right, this is the area of a circle. And what is the area of a triangle? It is 1/2 base times height, right? It's the area of a triangle. So maybe I could do one or two questions from the backside just as an example. Um, let me do 47A. So 47A is asking for the integral from 0 to 2 of f of x, right? And so on the graph, what does that correspond to?
0 to 2.
Yeah, you need to have this to see the question.
Right.
So f of x from 0 to 2 is right here, right? We care about this area here because this is 0 and this is 2 on the graph, right? And this is -1 and -2. So the integral from 0 to 2 is going to be that area there. Is it negative or positive? Is it negative or positive? It's a negative area, right?
Yeah.
Because we're going from 0 to 2 and the area is below the x-axis. So that's a negative area. And so what is this area? This is a quarter circle, right? So it'll be 1/4 times pi. What is the radius?
5.
2 squared. So 1/4 pi r squared, which is equal to pi, right? And then these should be negative.
What's that? 4 something over something. What is that? The one that's on the top bar.
It's supposed to say 47.
Oh.
My thing is glitching.
Okay.
Okay, so the answer is negative pi, negative because it's below the x-axis, and you just find the area using geometry. Let me do an example where we have some triangles. So let me do 48. Which one's a hard one? 48. These are all kind of tricky, actually. Yes.
You have a paper. Oh, it's on the best.
Let's do 48 F. 48F. So 48F asks us to do the integral of 4 to 10 of f(x), correct?
10 to 4.
4 to 10. And so what does that area look like? So here is our x-axis. Where does it start at 4? It starts at 4 comma 2, right? So this is 4, 2. You don't need to draw it because you have it on your paper. But 4, 2, and then it goes down to 8, -2, and then up to 10, 0, right? So it crosses back at x equals 10 at 10, 0. And so what does that mean? We're interested in this area here. So this plus this. However, this is a positive area, right? And this is a negative area. So they're actually going to end up canceling out. So we need to keep careful track of what is positive and what is negative. All right. Where does it cross the x-axis? Crosses at 6, 0, and 10, 0, right? So in order to do these questions, frequently you'll have to split up the thing into different segments, right? So probably the best way to calculate this is by splitting it up into 3 parts and then calculating the area of these 3 triangles. I can label them like this. So maybe this triangle is number 1, this triangle is number 2, this is number 3. So triangle number 1, what is the area? Let's see. So the area is 1/2 base times height. What is the base?
4.
The base is 2. The length of the base, right? This is length 2. So the base is 2. The height is also 2. And so the area is 2. 1/2 times 4. Yes, 2. Um, what is the area of part 2? Once again, the base is length 2, right? And the height is also length 2. But this is a negative area this time, right? Because it's under the x-axis. So this will be negative 2. And then 3, you can do the same process. It should be negative 2 as well. Okay, so we've split up this integral into 3 different parts when we calculated the area separately. And so that tells us that the final answer is going to be negative 2. I just need to add all the areas together. 2 minus 2 minus 2, negative 2. Any questions? So today is really all about, thinking, geometry, no math, right? No real math. Let me briefly talk about a Riemann sum, and then you guys can go ahead and do it. What is a Riemann sum? Sounds quite complicated, but it's not. So a Riemann sum is basically just a way for us to approximate the area under a curve. So suppose we had our curve, or no, suppose we're trying to calculate the integral 0 to 5 of x squared dx. Okay, so we're trying to calculate the area under x squared from 0 to 5. And as you guys know, the graph of x squared looks like this, right? It's a parabola. So here's my function x squared, and I'm trying to calculate this area between 0 and 5. Maybe here's 1, 2, 3, and then 4. So I'm interested in this area here. I think it's mine. Yeah. Okay.
Yeah.
Food. That's a good answer. Okay, what is a Riemann sum? First of all, let's talk about what a left Riemann sum is. Basically, all we're doing is we're going to split this up into rectangles and use those rectangles to approximate the area. So a left Riemann sum will look like this. Okay, is this a good approximation? Not really. But as the segments get shorter and shorter, the approximation becomes better and better, right? As the segments become shorter and shorter, yes, then we have more and more rectangles and we'll get closer and closer to the actual area, right?
Yeah.
So why is this called a left Riemann sum? That's because we're taking each interval. So we have the interval 0 to 1, and we're looking at the leftmost coordinate, which is 0, and we're using that height to approximate the area. Make sense? Okay, what would a right Riemann sum be? For a right Riemann sum, which I'll label in green, we would take each interval and we'll look at the rightmost coordinate and use that height to approximate it instead. So if we had 0 to 1, we would use the 1 to approximate the height of that segment. So my right Riemann sum would look like that. And for 1 to 2, I would use the 2. For 2 to 3, I would use the height 3. And for 4 to 5, I would use the height at 5 to approximate that interval. So as you can see, if we were to calculate the right Riemann sum, then we would overestimate the area, right? And a left Riemann sum underestimates the area. That's not always the case, but one will be underestimating and one will always be overestimating. Any questions? Vincent? How do you do it? Um, you would just add the areas up. So you would find the areas of these rectangles, base times height, and do that for every single one. Okay?
Question.
Yep.
We need to use the numbers.
Mhm.
So like it won't look like that.
On the quiz, you'll get the numbers for the function. You'll see. We'll talk about that later. Just introducing it for now. It will be very easy. Very easy. So that is not a very good approximation. What is a better approximation? There's something called a trapezoidal sum. And it's a better approximation because instead of using rectangles, we are going to use trapezoids. Trapezoids. So let's say I have, once again, 1, 2, 3, 4. Instead of using rectangles, I'm going to take these coordinates, so the coordinate at 1, 2, 3, and 4, and I will use rectangles to, trapezoids to connect them. Like this. It's hard to see because it's such a good approximation, right? Okay. Wait, I skipped one.
Yeah. It was almost perfect. It was so.
Should I draw the points bigger?
There's semicircles, you see that? No,
Yeah.
So instead of a curve, now I have trapezoids here. Oh, a trapezoid is a quadrilateral where two sides are parallel.
Look at two straight lines. It looks like this.
Okay. So actually, if you think about it, this is actually going to be the average of the left and right Riemann sums.
What's it like?
That is because the area of the trapezoid is actually just going to be equal to the average of this rectangle here and this rectangle here. Okay? Do you guys agree with this? This is horrible. Does this make sense at all?
That's a stop sign, right?
Oh my gosh.
But there's two parallel.
The blue area is the average of the green and yellow areas. I think this is just kind of confusing at this point. Let's just talk about this in another class and you guys can do the classwork.